All right, pre-cal. Today we're going to be talking about quadratic functions. And so let's go down the list of what we need to know in regard to quadratic functions. So the first thing we're going to talk about right here is the polynomial standard form of a quadratic function, which is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. And so we'll be referring oftentimes to this format. And you're pretty familiar, I'm pretty sure y'all are pretty familiar with this format. This is like when we see a function and we write it as y equals whatever. I'm making up numbers here, 2x squared plus 3x plus 4, right? The reason why we say ax squared plus bx plus c is so that you have a consistency in the order. Because if you know, sometimes these equations can be scrambled up. So if we see something like 3x plus 2x squared plus 4, and you wrote it as 2x squared plus 3x plus 4, it gets a little confusing. So the only reason why we put it in this order is to have some consistency so that we all are talking about the same thing in the same order. Next, we have the X-Intercept form of a quadratic function, which is sometimes called the factored form. And the factored form is in such a way that you essentially have the zeros written. Okay, and that's important because the X-intercept is in fact the zeros. So the benefit of this is that they're in the zero form. So for example, if I give you f of x equals, notice we can interchange y with f of x. So f of x equals, let's say, 2x minus 3 times x minus 4. Well, we know what the zeros are, so something that is very important if you don't know this already, the x-intercept is when y is 0. So anytime we talk about an intercept, the other letter is 0. So the x-intercept, y is 0. The y-intercept, x is 0. And so when we look here, we can see very easily that f of x or y would be 0 if x was 3, right? Or if x was 4, right? Because with either 3, well, let me be consistent here with 3, or if we said 4, right? Either way, with either 3 or 4, it doesn't really matter what happens except for the fact in this one that 3 minus 3 becomes 0, because 0 times anything is 0. And in the latter one, that 4 minus 4 becomes 0. You don't really care about anything else because 0 times anything is 0. So that's that format. What's next? So we have the transformation form of a quadratic function. This is sometimes called the vertex form. And the reason why this is called the vertex form is it gives you the vertex, right? The vertex is hk. So if you have something in the format of f of x equals 2x minus 3 squared plus 4, then we know instantaneously that hk, or in this case 3 comma 4, is going to be my vertex. Okay. Notice here that with the 3, it says x minus 3, but here it is a positive 3. So notice the flip. Some people say insides are a liar. I like to joke around and say, well, what do you learn from your x? You learn that you like the opposite. So if it's negative 3, then it's positive 3. But it is the opposite, so it's going to be 3 comma 4. Notice not negative 3 comma 4. Okay, and again here we see that exactly what I'm talking about, which is that it's the opposite effect. So x minus h, and then here we have x plus h, which is negative negative h. So again, if you see x minus 3, it means you're going to shift 3 to the right. If it had said x plus 3, we'll shift 3 to the left. With the vertical shift right here, it's going to be exactly what your intuition tells you. So notice 4 is still exactly that. It's up 4. Okay. If it was a negative 4, it would have just been down 4. Okay. The directional opening is exactly what we've what you think intuitively, which is we said if the function is positive, you tend to smile, so it goes up, and if you're negative, you tend to frown, so it goes down. Okay? And the steepness is very similar to what you would do with a linear function. So what I mean by that is the greater the a value, or I should say, the greater the absolute value of a is, the more your graph tends to hug the y-axis. So if you have something like y equals 2x squared versus something like y equals 10x squared, what we see is that in blue we have 2x squared, which is further out, right? Right here, this is further out than the green, which is 10x squared, which is more in, right? So what essentially happens is just like the steepness of a line. I like to say the a value, the bigger the a value, the more the graph tends to hug the y-axis. The other way that people like to talk about it is sort of like a rubber band effect. So what you can see here is that in this image here, when you stretch a rubber band, so in other words, the values are getting bigger, the values being a getting bigger, the parabola becomes narrower. Whereas if you're not stretching it, the a value gets smaller. Again, we're talking an absolute value here, so we're not talking about -3, -4, and it becomes wider. So that's sort of a way to think about it. In any case, let's go back. So that's where we're talking about this right here. Okay, next up we have the axis of symmetry. And all the axis of symmetry is the line that divides the parabola in half. What's nice about a parabola is that it is symmetrical. So whatever you go to the left, you go to the right in equal amount. So it is symmetrical with y equals I was about to say y equals x, but I really should have said with the axis of symmetry, which is x equals h. Which also means that, for example, if I'm using this example here, right, that all you have to do to find the axis of symmetry is take this part right here and set it equal to 0. If you actually set that equal to 0, we'll get x equals 3. And later I'm going to show you guys why that's the case. Okay, then we have the domain. And the domain, the parabola sticks out, so that means it goes out forever and ever, so it's -infinity to infinity. And the range is going to depend upon where the vertex is. So if the parabola opens up, then it's going to be whatever is the y value here, which we call k, and above. That's why you're seeing k is greater than from k to infinity. If, however, the parabola is negative, and when we say the parabola is negative, we mean the a value is negative, it's opening down, it's frowning, in which case k would be the maximum value, so it would be -infinity to k. Notice that we do include k, that's why you're seeing the brackets here. Let me erase it because my pen is a little too thick. But this is also why k is a bracket, because we are including that value. So I know that's a lot. When we do the examples, hopefully it'll make a little more sense and be a little clearer. Okay, so let's do that. So let's look at example 1. So which of the following figures most closely resembles the graph of y equals a parentheses x minus h squared plus k? Basically, it's in vertex form. Okay, so let's see the first one. So we say for the first one, we see that a is less than 0. So what do we know about a being less than 0? Well, if we refer back here, we know that if a is less than 0, it means that we have a frown, right? It's opening down. So that means I can eliminate a. It could be b, it can't be c, and it could be d. Next up, we know h is positive, right? So with a positive h value, what does that mean? That means like in here we have something like x minus 2 squared plus k. Sorry, my pen was acting up. Plus k. Okay, so what does this mean? Well, we know that we said that it's the opposite of x. So this minus 2 means you're going to the right 2, which means that D is not possible, but B is, because we know it's shifting to the right. So this means we're shifting to the right. Also note that we didn't have to worry about k in this problem, but if I did want to concern myself with k is negative. This is a little tricky, but this is the x and the y-axis, so this is below. So we know for sure that the first one has to go with B. Okay, let me erase these now. So we have a little, I'll leave B. Actually, I'm going to erase everything. And let's start over. We now know that B is gone, though. I'll cross out B because no matter what, B is gone. Okay, so let's look at example 1B. And so in example 1B, it says A is negative. So we can very easily deduce that this has to be the answer because it's the only one that's left that's negative. But let's see why it makes sense. So notice that h here is less than 0, so it's negative. So it'd be the opposite of this one. So whereas A was like in this example, was like x minus 2, and so it would go to the right. In B, we're going to go to the left. So that makes sense that it's to the left of the y-axis. And then K is positive, which means we'd be above the x-axis. So that makes perfect sense. So now we have another one eliminated. I'm going to, you know what? I'm just going to do this. I'm just going to cross this out now because we know that that's gone. We're only left with the positive ones. Now, what's really interesting is that we know we're on the right track because A is greater than 0 and A is greater than 0 in both C and D. So we know we're on the right track. We, again, piggybacking off of what I did in A, we can see that if H is greater than 0, we know we're shifting to the right. That doesn't really help us because both A and C are shifted to the right. Notice that they both say H is greater than 0. So that does tell me something that's important, which is that I am on the right track, right? Even though it doesn't give me the answer, it does tell me I'm on the right track. Then we look at C, we're looking at C here, and we see that also that the K value is less than 0, which means that we are going to be below. So K is less than 0, which means we're going to be below the x-axis. So the vertex should be below the x-axis, which is going to leave me with the answer choice being C. I didn't see it originally. I thought this purple line was the x-axis, but if we look closely, we can actually see the x is down here. There's supposed to be a line here for the x-axis, which would make sense that because the k value here would be up. So that tells me that that C is going to be C, and then D is going to be A. So I hope that makes sense. Let's move on to the next pen, or next page. Okay, so now we're actually going to graph it. So this is for the function f of x equals -4, quantity x minus 2 squared plus 4. Find the vertex, the x and y-intercepts, then sketch the graph. Okay, so what am I going to do here? Well, we know that hk is going to follow this, so we know that the vertex is simply going to be 2, 4. Okay. Notice that with the h value, I put the opposite. So this is x minus 2. So it's going to be 2. And when I say the opposite, it's because it's saying visualize x minus 2. In reality, this is actually saying x minus h. So h is positive 2. But because it says a negative 2 here, that's why I'm saying the opposite. So next up, we want to talk about, well, how do we find the x-intercept? Well, the x-intercept, we know from earlier that the x-intercept is when y is 0. So what are we going to do here? So we're going to take, and I'm going to rewrite f of x as just y. We're going to say y equals -4, x minus 2 squared plus 4. So I'm not doing anything fancy here. I'm just rewriting the equation. The x-intercept is when y is 0. So we literally just solve the equation to solve for x. So how do we go about doing this? Well, it would make sense to subtract 4 from both sides. And so we'll get negative 4 equals negative 4x minus 2 squared. Then we will divide through by negative 4, which is comforting because we're going to get a positive 1, which is necessary with what we're going to have to do next, which hopefully you see is take the square root of both sides. So this is going to give me plus or minus 1 equals x minus 2, which now means I got to break this into two scenarios. I have 1 equals x minus 2, and then I have negative 1 equals x minus 2, and we're going to solve. So plus 2, 3 is x. Here we're going to go plus 2, x is 1. So we see the solution is going to be 3 comma 0. Notice it's 0 because the y value is 0, and 1 comma 0. And that's going to be the value. So we have, these are going to be, let me clearly define, these are our x-intercepts. Again, the x-intercept is when y is 0. Okay. So now that we have the x-intercept, it probably makes sense to go after the, yep, you thought it right, the y-intercept. So we'll put the y-intercept here. So what's the y-intercept? Well, first let's write the equation again. Again, I'm going to write it in terms of y instead of f of x. It doesn't matter. You can call it either way. And now the y-intercept, remember we said the other letter is 0, so now it's going to be x is 0. So the y-intercept is when x is 0. So we're going to go in here and we're going to make, I guess I'm going to have to go through it. We're going to make x 0. So we're going to rewrite everything. Notice all I've done is made x 0, and I solve. So this is nice. This is going to become negative 2 squared plus 4. 0 minus 2 is negative 2. Please follow PEMDAS. So PEMDAS says you got to do exponents before you multiply. So you have to do negative 2 squared. Notice negative 2 is also in parentheses, which gives me negative 4 times negative 2 squared is 4. Negative 2 times negative 2 is 4. And we're left with such. And then y, so multiplication, negative 4 times 4 is negative 16. If you ever have any doubts about what comes next, you just follow PEMDAS. So negative 16 plus 4 is negative 12. So this leaves me with 0 comma negative 12. Okay, so we have enough information to graph it. So let's graph this. So we know, well, first off, I think these are in what, increments of 8. So we have 8 to the right and 8 to the left. I think 8 up and 8 down. Let's see, do we have enough space here to fit these? We got 3, 0, 1, 0, 0, negative 12. It looks like we don't, but I'm still going to go by ones. And I'll just embellish the y-intercept. So let's start with 2, 4. So 2, 4 is going to go, here's 2, and 4 is going to go 1, 2, 3, 4. So we're right there. There's 2, 4. Okay. Now, if that's the vertex, then we also know that we have a line going straight down here, which would be the axis of symmetry. We now will go ahead and graph the x-intercepts, which are 3, 0, and 1, 0. So we have 1, 0 is right here, 3, 0 is right here. Notice that both of these, and I can't change the font size, so it's going to be a little big there, but we only jumped 1 to the left and 1 to the right. And that should be the case from the axis of symmetry. And in fact, that's how you know that you're on the right track, because if that's not happening, you did something wrong. Now, we also know, let's say negative 12 is down here, so we know that this thing looks something like this. Okay? This makes sense. This is negative, right? A is negative, which means it should be opening down, right? We draw the vertex we draw points of intersection, and we go. In general, if you have any sort of concerns, you can always just throw in points and see if it's true. Okay? But that's basically it. So let's look at the next page, and we're gonna figure out what graphs match with what. So let's look at the first one. So the first one says g of x equals x squared minus 5. So what do we know from this? Well, if you're looking at this and you're a little confused, realize that this is just saying g of x equals 1x minus 0 squared minus 5. So all I did here is put into y equals ax minus h squared plus k, or vertex form, right? So what does this tell me? Well, the only interesting effect that's happening here is this minus 5. Well, I shouldn't say that. We also know that a is 1. So there's two things. One, we know it's positive, so that means that 1 and 2 go away. And if you want the answer to that, it's very clear that that's going to be the case because they're frowning, they're negative, right? And we know that it shifts. The only sort of shifting of the vertex is it goes down 5. So I can eliminate 3, and I hope you see why I can eliminate 3, because it's shifting to the right, right? We're not talking about shifting right or left. It just goes straight down. 4 goes away because it's shifting to the left. 5 goes away because it's shifting to the right. I sure hope 6 works. Oh, look, 6 goes straight down. And we can see it goes down 1, 2, 3, 4, 5. It does go down 5. So that is correct. So we know that A goes with 6. Let's jump to B. Now all I'm going to do here is just erase these. You know what I'll do with 6 is I'm going to draw a giant X through 6 because we know that's gone. Okay, so what do we notice about B? Well, B starts off with a negative, so that means it's got to be a frowny face, which means that 3 goes away, 4 goes away, and 5 goes away. This is nice. We also know that it's very similar to A, right? It's plus 4, so plus 4 means you should be shifting it up 4. So we can see here that 1 shifts to the left 1, and 2 shifts up 4, so that's going to go with 2. So this one's going to be 2. Okay, so let me erase everything except the giant X, and now I'm going to put a giant X through 2. I'm also going to change the color. Let's go to C. So C is, first off, notice A is positive, so we know that 1 can't be correct. And we also know that we have something going on with the X value. So it says X minus 1, which means we're going to shift to the right 1. So what that means is that we're not going up and down. So notice 4 and 5 got to go away because they're both shifting down, right? I'm assuming. Well, they're definitely not on the origin. So yeah, we're not seeing any y-axes here for 4 and 5, which is a little strange, but that's okay. We'll deal with that when we get there. We can see here too that this actually shifts over to the right 1. So 3 is going to be for C. Okay. Again, I'm gonna erase everything. We'll put a giant X through 3 because that's gone. The next one is really easy and straightforward. We know that it's negative, so the only negative one left is 1. So this has to be is. But it also works because it says plus 1, which means we should be shifting to the left 1. Okay? So X is the opposite, move to the left 1. So that's cool. Okay, so that's 1. So now I'm going to cross that out and get to the interesting part, which is E and G. So with E, what we see here with E is we have X minus 1. Well, first off, I guess we should say A is positive, but we know A is going to be positive for both of these because that's all that's left. X minus 1 means we shift to the right 1, so it should definitely be to the right. Now, it says plus 1. I'm assuming that the x-axis is right here. But even if that's not given, it can't be 4. It's got to be 5. And then we'll see the following one is x. Look at the next one. It's x plus 1, which means you shift to the left. So that one's got to be 4. And there you have it. So this is just you got to remember when it's related to x, it's the opposite. You got to remember the number in front of x, the leading coefficient has to be, if it's positive, it's a smiley face. If it's negative, it's a frowny face. And then the k value, the one on the side, like these plus 1s and this plus 1 here, that's shifting you up and down. Okay? And it's exactly what your intuition says. So you see a plus 1 is shifting you up 1. Both of these, I think we're to assume that the x-axis is down here. But if it was a minus 1, then it would be below it. Okay? Let's see here. All right. So in these examples, you're actually going to sketch it yourself. So what does that mean? Well, for the first one, x minus 4, we know the minus 4 means we shift down 4. So it would be down here. And this would be negative 4. For the next one, b, we know the minus 1 means we're going to shift to the right 1. And we're going to draw this down. Notice when I draw this one, it's got to be super... This should be super narrow because 1/10 is oh no, that's wrong. 1/10 is very small, so actually this should be very wide. I'm drawing this wrong. It should be very wide. But the X-Intercept, the vertex shifts to the right 1. Okay. Now C is actually really interesting because I always like to do this when I'm first learning this. Let's write it as such. I'll write it as such. And what this tells me is that we're just shifting it up 2, right? And then the negative means it's going down. It also is narrow because this negative 3 is, remember we're talking about absolute value, so it's if it's greater than 1, the bigger the absolute value is, the narrower the function is. In other words, the more it hugs the y-axis, the more we're stretching the rubber band, right? And the best example here, the one that I really like, is D because it gives you everything. So the plus 3 means we're shifting to the left, negative 3. Let's not forget this is 2. Left, negative 3. The plus 4 means you're shifting up 4. And then it's positive, so it's opening up, and it's a little more narrow than the regular one, like an A. Okay, so the regular being the parent. Okay, so we have something like such. Okay, so hopefully that makes sense. And actually, I got about 2 more minutes before I'm up in terms of the amount of time that I can make a video. So I'm actually going to stop this one here. We still have some more. We're about halfway through. So next time we'll pick it up with polynomial form. All right, y'all. Hopefully this makes sense and it's helpful. And I'll catch y'all in the next math video.